welcome from my side. My name is Hans-Martin Heinkel from Bosch, and I and Karl-Michael Hahn from Opel Stellantis will make a presentation about simulation-based secretable simulation process and especially the calibration process. As a starting point, I would like to show you the credible simulation process framework. This picture was already shown by the presentations from Stefan Rude, and it is based on the evaluation of about 20 companies. And if you clearly go to the basics of the processes in these companies, that will occur. So on the top level is a product development process itself. And within a product development process, you have thousands of decisions. That means design decisions and also release decisions. And on the next level, there is a single decision, and therefore we need a decision process. And here we need the input, what is the task, that special task, and here it must be defined which subtask that decision can be made, and this subtask can be real tests, and it can be also a variation of simulation tasks. And then within the decision process, they will collect these results, and based on these results, they make an overall result and make a decision. And that part, which you see here, that is core of the public funded project VV methods. And we here in the Z-level project are focusing on the credible simulation process and the credible modeling process. So what we need is a clear input. What is a specific simulation task? And then we have to follow that row of process elements. And we also need, if we want a credible simulation, we also need credible models. So underlying our sub-process like the credible modeling processes. And what's important, it is here, we need all that information for the proof and documentation of the quality for a decision based on a simulation result. And what was very important for us when we made that process frame, that it can be used within the Z-level project, but it has a structure that it can also easily integrate it, especially the sub-process, into the specific company processes. So it's not necessary that in a company everything has to be changed, because the upper-laying process structure is normally already available, and you can use these sub-processes and easily integrated in the specific company processes. In more detail, we will give a presentation tomorrow morning. Now, to the main part of what we want to show here. So the extremely important point, how does it look like when you are working together, not only within your company, but with external partners. So here, a very simple example, partner R, an OEM, wants to develop an automated driving function which uses a camera signal. And therefore, he needs a camera, but if the camera itself is not available, he wants to use a model of that camera. And therefore, it is necessary that the partner B, a tier 1, gets the information within the modeling request that he can develop and deliver the right model, which can easily integrate it within the simulation process of partner R. What you see here is the development part of the process. And in difference, if you are simulate within your own company, if you are working together with another company, with a partner, there is also the so-called agreement processes in front of the development process. And the collaboration process, therefore, always is composed of an agreement process and the development process itself. And the focus of the agreement process is the clarification and definition of the technical and contractual boundary condition for a simulation between the partners. And focus of the simulation modeling process, that is the joint specification and design and implementation. And what's very important, that normally between partners, not the main point is to develop a model, but to develop a product. So there is normally a higher level product development agreement, and only as an development aid also the simulation models. And often, however, these simulation specific aspects are not fully clarified in the agreement process. And that is also one of the key findings within our project. And what you see here is on the upper level, the credible simulation process, and here is the credible modeling process. And now we go more in detail. What does this coordination looks like? And therefore, we skip Z to the right and Z to the left. And then we come to that picture. So here is a credible simulation process from partner A, the OEM, and here from partner B, the credible modeling process. And in between, you see this coordination process with all these elements which are necessary that you get the right model and can use it within your company. And if you want to have here more details, so the more detailed description are available on our internet pages. And what we want to do now, and what we have done within our project, so we play through in couples a typical development based on simulation. And because in these companies, hardware in the loop simulation, also incorporation, is established for more than 10 years. And so we made workshop with these experts who have really experience in simulation and incorporation based on simulation. And therefore, we now want to give you an overview about our findings, what we have specially explored and gathered within these workshops. And now I want to give the word to Carl Michael Hahn from Stellantis, and he would start with this explanation. Kalle, now it's yours.
Yes, thank you, Hans Martin. Yeah, I had the pleasure to share in those workshops. As Hans Martin mentioned, I could share my experience of many years with such projects. Working as an OEM simulation guy with many tier ones, from project definition to SOP, I learned one thing especially. This stuff is complex in the true sense of the word. And we can handle complexity only together. It's not possible alone and not against each other. So we really need such a collaboration aspect and process to work together. And the first point that we would like to highlight here is that it's important to involve experts. These projects are complex environment. It's not just repeating a previous project. Especially with highly automated driving functions, there is so much that has to be considered, and there is not that we have done it many times before. So it's complex. And that is why it's so important to involve all relevant experts to understand what is the latest best practice and to extrapolate over the next years. Also, these projects run typically for several years, and we have to foresee what's coming. And we have to ensure that those learnings from hardware in the loop and from modeling, from simulation, learnings about what is important regarding tool chains, versions, and methods. That all these learnings are heard, that it's known in the project setting, and that it's taken into account for the agreement process. And then we can achieve something that is also very important and becoming more important, the traceability. And Hans-Martin will share a little bit about traceability.
And I will first add some words because when you are working with a partner for many years, it's you have some experience. But now in the field of automated driving functions, also new collaboration starts. And here it's very important that here not only the sales department is involved, that here are really the new experts from both companies sit together already in these early phases. So that is a very key finding from us. And the other thing is, because that is in a change in the moment, that in future, especially in the field of automated driving, so quality assurance and therefore traceability is very important, especially if partners are working together. So the normal information chains are broken because the IT systems are not connected. So you exchange information packages, and therefore you have to ensure in some way how you can, for example, as an OEM, can guarantee traceability even if a part of this information chain is not within your house. And that should be somehow established in the beginning of the project. Well, Kalle, do you want to say something about requirements?
Yes, we made this bubble requirement discovery workshops, and I like this discovery idea. It's that we have to discover the requirements. It's not clear at the beginning. We have to have a lot of communication. We have to clarify openly what models shall be used for, which models are available, and what are the assumptions behind these models. This is important that we make it clear early, that we understand models are available for a certain purpose. And it is also very, very important that we ensure the same understanding of terms that exist. Even such an easy term like hardware in the loop, there are different interpretations, different ways that we use hardware in the loop. And there are so many problems arising from different languages, even in the technical terms. So it's important to define what do the terms mean. In the end, we need a glossary, a common glossary for the project. And we have to define in these discovery workshops what are the tools that we use and what are the roadmaps of the tool versions, because the project run long, they have a long time, and tools change over the time, and we must ensure that we will not have incompatibilities that lead to additional costs and delays when we are not aligned on that, and especially aligned in large organizations. And we must speak about model parameters. It's not enough to agree on models. The models must be parameterized at the right time and with the right quality. And this also can be very challenging to organizations as they are today. Imagine that a model will be released only if it's based on a validation in a real prototype. But at the same time, the model is meant to replace the real prototype. And we have a deadlock, and this has to be worked out early and understood early in the project setting. Hans-Martin.
Okay, then I will continue because what Kalle mentioned is very important, but also it's very important that you refine your requirements iteratively, because during the development process, things can change, and then you have to look, are your requirements are still totally valid, or as they have to be adapted. And that's also a very important point. And now we came to the topic of test cases. Kalle, as I know, that is one of your favorites.
Yes, it's a favorite thing where we can have a lot of misunderstanding also. We have to make clear what do we want to do with models. We want to, of course, we want to execute tests in the end, but we also have to have a clear strategy regarding the verification and validation. It is one task to ensure that the model is working according to expectation with all its assumptions and limitations. So make sure the model does what I want. And if that is ensured, then we can go to the next task, the more important task, to check if the product represented by the model is working according to the expectations, according to the product specification. Both tasks are important, but they require different tests and test setups. And we have to make sure that we understand that we speak about it clearly, that we define what are the tests that we do for ensuring model quality, and what are then tests to ensure product quality.
Well, then I can also add, and I would like to make it in also in different words, because the test cases is a very, very important point, because they are also the acceptance tests. If, for example, a supplier, a tier, is give over a model, there are acceptance tests. And so it's very important who is responsible for which tests. Because to say, well, for all tests, the OEM is responsible. We saw it's not fully the best way how to work together. And it's like Colin also, as I say now, so the test cases which are more according to the system, to the product, here the experience is really on the side of the OEM. And so the acceptance tests according to the system and the product, the overall product, that should be in the hand of the OEM. And on the other hand, if we are looking to the component and the model which is delivered, that should be responsible in the responsibility of the supplier, because here are the experts who really know what is in that company with, component which has to be delivered and what should be in the model. So that should be in the responsibility, and the acceptance, that part of the acceptance test should be in the responsibility of the supplier. And that is, in our point of view, one of the critical and important point in the beginning of a project, that you really clarify your acceptance test and the test cases which should be fulfilled. And now to the next point, standards. So a real important point is for us that we have more standards, not only standards for exchange, also typical standards like FMI, SSP. So we also need some standard interfaces for components, for example, for a camera, for sensors, also for part of the vehicles, because that is very costly. And if you have to adapt the interfaces of the models, and which is not clear what effects are inside or what effects are outside. And if we have here some standards, and that should be done by parties like the FMI or ASAM or other bodies. But that is another, our opinion, a very, very important point if we want to make the simulation-based development efficient. Kalle, do you want to add here something?
I fully agree with you. So I'm absolutely a fan of standards, and I really like that there have been new standards established, or existing standards have been established more and more, like FMI, as you said, because it's so important for exchanging and working efficiently together. So this is very good. And I would like to take one of these standards, the FMI, because it also helps in the next important aspect, which is the IP protection. So in a partnership, it should be a prerequisite that the IP is respected. And of course, model exchange is not for sneaking IP. So it makes sense to define rules and agree on mechanisms to respect and protect the individual IP needs. For that, a clear strategy is mandatory, especially as soon as the project is a multi-layer cooperation. Imagine it is often the case that an OEM wants to exchange a vehicle model with the tier one, but the vehicle model contains a subsystem of another tier. This has to be seen and managed early in the project definition and not in a late phase when it's too late to act. And of course, the IP protection has to be possible technically across company frameworks. And this is where standards like FMI are essential, and where they open us much more possibilities and allow us to work together much more efficiently than we were able in the past.